Hi Year 13. In this video, it's going to be quite short today. I'm going to extend what we did yesterday on integrating rational functions, and we're going to look at the ones today that are improper. So we're looking at integrals where we've got a rational function like this, but the degree of the numerator is at least as big as the degree of the denominator. So I'm going to write down this that characteristic like that so we can recognize it. Is greater than or equal to the degree of the denominator. Okay, and notice the or equal to that I've got in my inequality there. Okay, so this is a quadratic expression divided by a linear expression, which means that it's improper. So how to cope with these then is to use polynomial division to express this as a quotient and remainder. And then the quotient and remainder typically will be of a form that's much more easier to integrate than what we've got there currently. So, long division. I'm hoping that from last year, at the end of the year, we remember how to do this. Note that because we're likely to get a remainder, you can't do the grid method for dividing this polynomial on the bottom into the top. You've got to, unfortunately, use long division to do this. So we're going to divide x plus 1 into x squared. And if there's missing terms in your polynomial underneath the leading term, you're going to have to fill in with zeros. So I'm going to add plus 0x plus 0. And then we're going to divide leading coefficients into each other like this. So x into x squared goes x times. And then we subtract x lots of what we're dividing by, which is x plus 1. So x squared plus x. We're going to subtract this away. I use brackets because it forces me to remember that this minus is distributing across both of these. So x squares disappear, and 0x minus x gives me minus x. I'm going to bring the 0 down to start the next step. And then x into minus x is minus 1. And repeat, so minus x underneath and minus 1 underneath the 0. Subtract away again. And that will leave you with 0 minus minus 1, which is 1. Okay, so now the long division is done, we'll talk about what bit goes where in our integrand. So this is the quotient. And this is the remainder. So we write our expression as we would a mixed number, the quotient part, and then the remainder that goes on top of a fraction that divides by this as well. So now we're in a position to rewrite our integral. So this is x minus 1 plus 1 for the remainder, and then again divided by x plus 1. Great. Now we can integrate these pieces. Bearing in mind the first parts are both polynomial, so that becomes x squared over 2. Minus 1 becomes minus x, and 1 over x plus 1 will become natural log of x plus 1. And then plus c. And then we're done. Okay, so that's the general idea. Check, first of all, about this degree business as to whether you need to do long division. In particular, you need to do it if the degree is equal to the degree on the bottom, and then proceed from there. So I'm going to show you a couple more examples, and that will take you to the end of that part of the chapter. Okay, 2 more examples to have a look at. You're welcome to pause the video and have a go yourself. If not, just wait for a few seconds and I'll go through it for you. Okay, this second one here is the integral of x over x minus 1. Now, in yesterday's live lesson, I showed you a bit of a trick as to how to cope with these. We don't especially need to do long division. You could, for example, do my trick from yesterday of subtracting 1, and that's in the numerator, and that's going to make our integrand turn into 1. But then we have to compensate by adding 1 onto the end of that to cancel that subtraction out. So we expect we're going to get something like this, but I'm going to use long division just to check. So I'm going to divide x minus 1 into x. That's the way that I'd write my long division. X into x goes once. One lot of x minus 1 is just x minus 1. and the subtraction here is going to give you positive 1. Okay, so indeed, so you'll notice what's going to happen here. So our integral is going to turn into 1 is the quotient, and then 1 is the remainder. Okay, and notice that's exactly what would have happened if we used my rule up here in red. We would have got 1 for this part, and then the next part would have been 1 over this x minus 1. So it's the same. Right, now let's integrate. So this is 1 that integrates to x, and then another constant over linear is bound to give me a natural log, and because it's 1x and 1 on the top, it's just the natural log of x minus 1, and then plus c. Great. Okay, last example. This time we've got a cubic on the numerator and a linear on the denominator. That's clearly going to need a long division. And again, I'm going to fill in the gaps in my polynomial with zeros, so it's x cubed plus no x squareds plus no x's plus 2. Now I can divide in x squared here. X squared times these two gives me x squared plus, x cubed rather, plus x squared, and then subtract. That will give me 0 minus x squared is minus x squared. Bring this part down. X is into minus x squared goes minus x times. X times this term at the front is going to give me minus x squared minus x. Subtract away. 0 minus minus x is positive x, and then we're going to bring the 2 down as well. And then finally, x into x goes once. 1 times x plus 1 is x plus 1. Subtract, and we're left with 1. Okay, so again, quotient on the top, remainder underneath. So our integral, which I'm going to star, is going to turn into the integral of x squared minus x plus 1 for our quotient, and then 1 for the remainder, and that's over x plus 1. Right, now we can integrate. Hopefully you can recognise what this is going to be before I do it, but it's going to be x cubed minus 3 minus x squared over 2. 1 goes to x, and this term on the end, similar to the one over here, is going to be natural log of x plus 1, and then plus c. Okay, fantastic. So that's pretty much all that's left for that part of the chapter in terms of polynomials and rational functions. I'm going to attach some practice today for you to get on with, and hopefully you're going to get on all right with it. If not, drop me some questions. I'll happily help you out with it. Otherwise, have a great day, Year 13, and I'll see you soon.